The third type of word problem to discuss is mixture problems. By mixture problems, I mean combining two different mixtures that have different values to form a new mixture with a different value. A common example might be found with food. For instance, let's say you have a bag of salted peanuts that are valued at $2 a pound and a bag of cashews that are valued at $6 a pound. If you mix them together, the mixture would be valued at $4 a pound. In mixture problems, you are given some information about different parts of the mixes and have to use that information to solve a problem. Here's the first example. Nuts costing 90 cents per pound are to be mixed with nuts costing 65 cents per pound to make 10 pounds of nuts costing 80 cents per pound. How many pounds of each type of nut should be used? Once again, the first step is to identify your X value. It says in the problem that I have some 90-cent nuts and some 65-cent nuts. So I'm going to let X equal the number of pounds of 90-cent nuts. Since I need a total of 10 pounds altogether when I mix the two together, that must mean that I would need 10 subtract X, or 10 subtract the number of pounds of 90-cent nuts for my number of pounds of 65-cent nuts. I would say this is the most important step in mixture problems, is coming up with this second value. Then the equation would be 90 cents times the number of pounds of 90-cent nuts plus 65 cents times the number of pounds of 65-cent nuts would have to equal the value of that particular mixture. If you're going to buy 10 pounds at 80 cents per pound, the value would be 80 cents times 10 pounds, which is equal to $8. You can see that I have gone through and done the math here, and I get an answer right now of 0.25x is equal to 1.5. If I go through and do the math now, I would get x is equal to 6. So I know that I need 6 pounds of 90-cent nuts. However, the question asked how many pounds of each type of nut should be used. So once again, I am going to go back to my labeling part. I know that I need 6 pounds of the 90-cent nuts, and that must mean that I need 4 pounds of the 65-cent nuts, because 10 minus 6 equals 4. Another way to set up a mixture problem is by putting the information into a chart. The chart is always set up the same way, which many people seem to like. I am going to do the same problem again quickly, but this time I'm going to set it up in a chart that you might find useful so that when you are doing other problems, you might find it a little bit easier. So here's the same problem, but as I said, this time I'm going to set it up into a chart. The nice thing about the chart is always set up exactly the same way. I really have 3 different columns that I need to have for my chart. One of the columns is the item column, the second column is the amount column, and the third column is the total column. And this will always be the 3 headings that you will have for a mixture type problem. Then all I'm going to do is I'm going to start to put in the information. I have a 90-cent item. I also have a 65-cent item. I don't know how much of the 90-cent item I have, how many pounds of that, so I'm going to say that is X. And I also don't know how many pounds of the 65-cent nuts I have. But I know since I need a total of 10 pounds that it must be 10 subtract X. Once again, I would say this is the most important part of these mixture problems, is coming up with that quantity, the second part. The nice thing about all this is that now I know that if I take the item multiplied by the amount, I'm always going to get the total. So now I'm just going to go through and I'm going to be multiplying each one of these rows. I get 0.90x for the first total, and I get 0.65 times the quantity 10 minus x for the second row. My equation is still going to be exactly the same. I still need 0.90x plus 0.65, 10 subtract x, and it still has to equal the value of the mixture. The value of the mixture is 80 cents per pound times 10 pounds. So you can see that the equation is exactly the same. And of course, the answer is going to be the same. But many people find that putting it into a chart helps to get that equation, and you might find that useful. Here is another mixture problem, but this time I am going to do it by going straight to the chart. How many pounds of coffee, which sells for $3 per pound, must be mixed with 100 pounds of coffee that sells for $4.50 per pound to make a mixture selling for $4 per pound? Once again, when I go through and set this up in a chart, I am going to need 3 different columns. And the column headings are always going to be the same: item, amount, and total. As I look at the problem, I have a couple of different items that I am going to be combining. One of the items that I am going to be combining is $3 coffee per pound. The other item is $4.50 per pound coffee. It asks me in the question how many pounds of coffee which sells for $3 per pound. So I don't know that amount. But it does say I do have 100 pounds of coffee that sells for $4.50 per pound. So I know the amount of that is going to be 100. Once again, whenever I do the chart method, if you multiply the item times the amount, that's always going to give me the total. So the total of my first row is 3x, and the total of my second row is $4.50 times 100. In this particular case, I know that I'm going to be making a mixture that sells for $4 per pound. And in this particular case, I could, if I wanted to, make a third row. The item is going to be $4 per pound coffee, and I know that I am going to be combining these two different amounts, the $3 plus the $4.50, in order to get the $4. So the amount that I'm going to have of the $4 coffee must be x plus 100. And once again, I'm going to multiply those two together to get 4 times x plus 100. So now my equation is 3x plus 4.50 times 100 has to equal 4 times x plus 100. Notice that in this chart we used 3 different rows. We used the third row to help us figure out what the value of that mixture was going to be. Now with this particular case, I would go through and I would just continue to solve this, and I'm going to do that fairly quickly. I get 3x plus 450 is equal to 4x plus 400. And then if I go through and subtract 3x from both sides, I'm going to be left with x on the right hand side. If I go through and subtract 400 from both sides, I'm going to be left with 50 on the left hand side. So I know that x is equal to 50. So that must mean that I need 50 pounds of $3 per pound coffee in order to make this work. Here's a problem that I would like you to work on by yourself before watching me solve it. Once again, I am going to be solving it, putting it into a chart. A man invests $3,600, one part at 5% and the remainder at 4%. His annual interest is $164. How much did he invest at each rate? So go ahead and set this one up and try to solve it, and when you are done, go ahead then and turn this back on again. Hopefully you have been able to work through this problem on your own. This is how I might go through and solve this problem. Once again, I'm setting up a chart: item, amount, and total. And one of the items that I have in this particular problem is I have an investment at 5%. The other item that I have is I have an investment at 4%. Now notice I put both of those into decimals because I am going to have to change them to decimals when I get to the equation. I don't know the amount that I'm investing at the 5%, so I'm going to make that X. I know that I am going to be investing a total of $3,600. And if X of it is at 5%, that must mean that the remaining would be 3,600 minus X. So that must be the amount that I am investing at 4%. Once again, to get the total, I'm going to multiply these two. So, on the first row, my total is 0.05x. In the second row, my total is 0.04 3,600 minus x. My equation would just be then 0.05x plus 0.04 times 3,600 minus x has to equal the value. Well, the value of this is $164 because that is the amount of interest that he is getting because he is investing part of it at 5% and the remainder at 4%. If I go through and solve this now, and once again I'm going to do this fairly quickly, 0.05 times, and then if I multiply 0.04 times 3,600, I get 144 minus 0.04x is equal to 164. And continuing to go through and solve this, I get 0.01x is equal to 20. And if I solve this for x, I get x is equal to $2,000. So if he invests $2,000 at X, that means that he invests $2,000 at the 5% rate, which must mean that he invests $1,600 at the 4% rate. So that is the answer to this particular problem. Once again, please remember that you might have set it up a little bit different way. You might have said when you went through and did the problem that the first item 0.05 wasn't the X, but instead you might have reversed these two. If so, you would get a different answer for X, but your final answer, 2,000 at 5% and 1,600 at 4%, would still be the same. As with the other types of problems in this module, you might want to practice several more of these types of problems, and you can find them in the module. As always, I am available through email or chat if you have questions.